In level 3, we will be solving radical and quadratic equations. And we're going to start with quadratic equations, and the first method we're going to be looking at is isolating the squared part, where we either isolate an x squared term or a quantity that's being squared. In the first example, we're just isolating x squared. To get x squared by itself, we would first add 81 to both sides, and we get 4x squared equals 81. Then I would divide both sides by 4 to get x squared by itself, and we get x squared equals 81 over 4. Now to solve for x, I want to get rid of that square. I take the square root of both sides, but I have to remember to put a plus or minus on the right side of the equation. And we get x equals plus or minus 9 halves. I'm going to write that as two answers, negative 9 over 2 or positive 9 over 2. In the next example, I want to isolate the quantity x minus 3 squared. So first I'm going to subtract 10 from both sides, and we get negative 4 times the quantity x minus 3 squared equals negative 25. And then I divide both sides by negative 4. And we get x minus 3 quantity squared equals positive 25 over 4. Now again, I take the square root of both sides to cancel out the square, and I have to remember a plus or minus on the side with the number. So we get x minus 3 equals positive or negative 5 halves. Now in this one, since I haven't gotten x by itself, I'm going to split this into two equations. One is x minus 3 equals positive 5 halves, and the other is x minus 3 equals negative 5 halves. In the left-hand equation, when I add 3 to both sides, that's the same as adding 6 halves to both sides, common denominators. We get x equals 11 over 2. And in the right-hand equation, add 3 to both sides, which again is adding 6 over 2. We get x equals 1/2. The next method we're going to use to solve quadratic equations is solving by factoring. In this method, we don't have one squared term that we could isolate easily because we have other terms with variables in this first example, so that method won't work. And this one actually has a greatest common factor. You always want to check for a GCF first. All of these terms have a 3 going into them, and they all have at least one x. So I can factor out 3x. But whenever I factor, I find it easiest to have a negative leading coefficient, so I'm going to factor out the negative, so my first term comes out positive. So I'm going to factor out negative 3x. And negative 3x times positive 4x squared gives me negative 12x to the third. Negative 3x times negative 7x gives me 21x squared. And negative 3x times negative 2 gives me positive 6x. Okay, now I'm going to continue factoring, and this part can be factored into two binomials. If I put 4x here and x here, that multiplies to the 4x squared, and then I need two numbers that multiply to negative 2, so I'm going to use 1 and 2, which gives me 1x and 8x, and these two terms, if my 8x is negative, that adds up to negative 7x. So I put my positive sign here to give me the positive 1x, the negative sign here so that my outer terms multiply to negative 8x, and it's factored. Now I'm going to erase my work here. And now I'm going to solve for all the values of this equation that make it equal to 0. This first part can make it equal 0. If we had a 0 there for x, the whole equation would be 0. My second part could be 0, so I make an equation 4x plus 1 equals 0. Subtract 1 from both sides, 4x equals negative 1. Divide both sides by 4, x equals negative 1/4 is a solution. And my last equation could equal 0 if x was positive 2. And those are the three solutions to this equation. This actually isn't a quadratic equation because it has an x to the third, but it's good practice factoring and finding all the solutions. The second example I can also solve by factoring. Part B I could solve by isolating the squared part again like we did in the other method, but just to show another method. Both of these are perfect squares, so we can factor this to be the difference of squares, where you have two binomials that are the same, but one has a plus and one has a minus. The two terms that are the same and multiply to 9x squared would be 3x and 3x, basically the square root of 9x squared. And the square root of 49 is 7. That gives me positive 21x here, negative 21x here. When added together, those middle terms cancel, which is why we have no middle term up there. So that works. I'm going to erase. And now I find the solutions that make it equal 0. For the first part to be 0, 3x plus 7 equals 0. Subtract 7 from both sides. 3x equals negative 7. Divide by 3. And x equals negative 7/3. Or for the other side to equal 0, 3x minus 7 equals 0. 3x, add 7 to both sides, and you get 3x equals 7. Divide both sides by 3, and x equals 7/3. So negative 7/3 and positive 7/3 are our solutions. The third method we're going to use for solving quadratic equations is your last resort when you have an equation that you can't solve by isolating the squared term and you can't solve it by factoring. And quadratic formula should work for any equation in the form ax squared plus bx plus c equals 0. And the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In this first example, first we need to get everything to one side, so it's set equal to 0, and we get 2x squared minus 2x minus 1 equals 0. This equation can't be factored, so I use the quadratic formula. My b term is negative 2, so the opposite of b would be positive 2, plus or minus the square root of b squared. Again, b is negative 2. Squaring that, you get 4. Minus 4 times a, which is 2, times c, which is negative 1, all over 2a. 2 times 2. And simplify this, you get 2 plus or minus the square root of 12 over 4. And then you always want to simplify your radical. The square root of 12 is 2 root 3, so 2 plus or minus 2 root 3 over 4. And then you can think of this as two fractions. If you distribute the denominator, it would be 2 over 4 plus or minus 2 root 3 over 4. And both of those fractions can be simplified. I get 1/2 plus or minus the radical 3 over 2. Okay, for this next one, I think you should put me on pause and try it all by yourself. If you ended up with a negative underneath this radical and didn't know what to do, you did it right. That means there's no real solutions. I'll go through it for you guys, but again, we want to have this set equal to 0, and I always like my leading term to be to have a positive coefficient, so I'm going to move the negative 3x squared over to the left side by adding it to both sides, and I'll get positive 3x squared plus x, and then I'm also going to add 2 to both sides, and it's set equal to 0. Now, again, this doesn't factor, so we use the quadratic formula. Opposite of b is going to be negative 1 plus or minus the square root of b squared, which is 1, minus 4ac. A is 3, c is 2, all over 2a, 2 times 3. And when you simplify this, you get negative 1 plus or minus the square root of negative 23 over 6. And because of this negative underneath the radical, this quadratic equation has no real solutions. The second part of level 3 is solving equations that involve radicals. This first one we would solve by isolating the radical, so I would subtract 7 from both sides, and you get 2 times the square root of 3 minus x equals 6, then divide both sides by 2, and you get the square root of 3 minus x equals 3. And then to get rid of the radical, we would square both sides, and we get 3 minus x equals 9, subtract 3 from both sides, negative x equals 6, and then divide both sides by negative 1, and x equals negative 6. In the next example, we would proceed the same way. We want to get the radical by itself. So subtract 1 from both sides, and you get 3 equals negative square root of x plus 1. Now we still don't have the radical by itself because of that negative sign out front, so we're going to divide both sides by negative 1, and we get negative 3 equals the square root of x plus 1. Now we have the radical isolated, but a radical is never going to equal a negative number. So we know right here that we're done and this is going to be no solution. Now if you had decided to keep going and you squared both sides, you would get 9 equals x plus 1, and subtract 1 from both sides, and you get x equals 8. When you plug in 8 to the original equation, it doesn't work, because if we plug it into the right-hand side, you get 1 minus the square root of 8 plus 1, 1 minus the square root of 9, which is 3, and that's negative 2, where we should have gotten 4. So this is an extraneous solution. You should always, always, always check your answers when you're solving a radical equation because they often have extraneous solutions. So make sure you plug them back into the original equation to see if they actually work. Okay, these are the last two examples in level 3, I promise. Part C is just an example where we're dealing with a radical that's not a square root. This happens to be a cube root, but we kind of attack it the same way. We would subtract 6 from both sides, and we get the cube root of x minus 2 equals 3. And then to cancel out the cube root, we're going to raise both sides to the third power. And you get x minus 2 equals 27, add 2 to both sides, and x equals 29. Now this last example is just a little more involved. We've got two radicals. So first we would get rid of that first radical by squaring both sides. And when you square the right-hand side, you need to remember that you have to multiply two binomials. So I'm actually going to write x minus 1 twice and multiply the binomials, which gives me x squared minus 2x plus 1. A common mistake is to just square both terms inside, but you're not allowed to do that. You actually have to write the binomial out twice and FOIL or distribute, whatever you call it. The right-hand side, one of those radicals cancels, and we get the square root of x plus x squared. Now my next step is going to be to isolate the radical that I have left. So I need this x squared to be subtracted from both sides, which actually canceled out the x squared on both sides. So now I have the square root of x equals negative 2x plus 1. And again, I want to get rid of that radical, so I'm going to square both sides. And once again, we have to multiply the two binomials. Negative 2x plus 1 times negative 2x plus 1, which is positive 4x squared minus 4x plus 1. And on the other side, we have x. Now we have a quadratic equation. We're going to subtract x from both sides and hope that this factors. So we get 0 equals 4x squared minus 5x plus 1. This does factor. 4x minus 1 times x minus 1 equals 0. Solve both equations. For this one, we're going to get 4x equals 1, x equals 1/4. And for this one, we get x equals 1. Now, again, you always want to check your solutions, and it turns out that neither of these work. If you plug them into the equation above, they both are false. So we have two extraneous solutions and no real solutions, so this is no solution.